The next example is the bridge as a crossing structure. So the example of crossing structures is one of them is bridge. This is the example of the bridge in Pont Alexander III in Paris. We use hydrology in the bridge, not for the bridge itself, because for the bridge itself we use the most of the knowledge that we use is from the structures, right? Not from the hydrological side, but we use the hydrology, our hydrology knowledge in the determining the elevation of the flood water level in the river. So as you can see here, the bridge is crossing the river. And in the beginning, how can we manage to know the elevation, like the exact elevation of this bridge, so the bridge is safe when the flood happen? Yeah, that's why we need to calculate the flood design flood discharge, and from the design flood discharge, we can get the flood water level in the river. And after we got the flood water level in the river, we can estimate where to put our bridge so that our bridge will be safe from the flood. So it can also be used even in the heavy rainfall. That's why we still need to use hydrology when we make the structure of the bridge. It apply in every bridge, like not only the biggest one, the big bridge, but also the small one. For example, a bridge in the rural area. Usually in the rural area, there are a lot of small river, and when we have a road, we need to build the road above the river. So that's why we need the bridge, or maybe we need the box culvert there. But the hydrology knowledge, it's used in every bridge design. Yeah, this is the example of box culvert or only culvert, because it's not always box. The dimension of the culvert is also based on the design flood discharge. As you can see here, there is this box culvert. There is also the circular one. This is also culvert. The left one is box culvert. The right one is the culvert. Usually, we use this box culvert when we have channel, and above the channel we have a road. Because road is more, not more important, but road is always above the drainage, right? We cannot make the drainage is above the road or high or same elevation with the road. The drainage channel always below the road, because when we have road, we also need to drainage the road. Like when there is rainfall going into the road, we also need to make the rainfall disappear from the road. That's why we need a drainage channel below the road, so that the water flowing from the road and then to the drainage channel, and from the drainage channel we can bring the water to the bigger channel, such as river or to the sea, and then we can prevent the road from the flood. This is the example of siphon. Siphon is also an example of crossing structures. Like we have bridge, we have culvert, and now we have siphon. What's the use of the siphon? It's quite different from the other crossing structures. This is the example of siphon in Kepanjen, Malang. Maybe if you are from Malang, or maybe if you are going from Surabaya to Malang, you can see in the Kepanjen Panjang area. You can see this big siphon. The dimension of the pipe, it's determined by the maximum flow of irrigation water that will pass through it. So it brings the water from the side to the other side. If there is a big river here, so we use siphon if we don't need the road, like if we need the road here, we can have bridge here. But for siphon, we don't use it as the road, as the vehicle road. We only use it as the water channel. Like here we have water from here. We need to bring the water from here to here, and then there is like a small river here, and the solution is only two: siphon or aqueduct or talang in Indonesia. Here we use siphon because it has quite high differences of elevation, and yeah, we can use siphon here. And as you can see here, the dimension of the siphon is bigger than the human dimension. Here you can see one person standing here, but the pipe of the siphon is approximately twice bigger than him. So maybe it's about 3 meters in diameter. But the diameter itself, it depends on the flow that flowing from here to here. Usually it bring flow from for the irrigation. So irrigation is needed need water, and usually the water is coming from the river, because water coming from the river is less polluted than the water in the channel, like in usual channel. So the water coming from this point to that point for the irrigation, it has such a discharge, and the discharge is determining the peak or the dimension of the pipe of siphon. Yeah, this is the other example of the crossing structures. As I mentioned before, the choices, if you have a channel and you need to cross the river and bring the channel to the other side of the river, you need either siphon or aqueduct. And this is in Indonesia is talang, aqueduct bridge. This is one of the oldest aqueduct in the world. And the aqueduct is on the 3rd floor. If you can see here, Lopong du Gard in France. In Lopong du Gard, it has a highway. The 1st floor is highway, and the 2nd floor it's used as the aqueduct. Here you can see the water flowing. Actually, they because it's made in the a very long time ago. So it's rather ancient, and the techniques is also still traditional. So they didn't make the aqueduct is in the same level with the highway. But nowadays, usually, we can make the aqueduct is with the same level as the highway. So here we have highway, and in the side, like on the both side, right side and left side, we have the water channel, the aqueduct, to drain the water from the highway and also from the rainfall. The dimension of the aqueduct is determined by the maximum water flow that will pass. So the principle is same, like to bring water from one side to the other side. when crossing the, for example, this one is the river. Yeah, enough with the example of the crossing structures. Now we begin to discuss about the water cycle. So we already know hydrological structures in the civil engineering side. For example, the dam, the weir, the reservoir, and we also have discussed about the culvert, the siphon, and the aqueduct. Now we will begin to discuss about the water cycle itself. So it's more hydrologic. The water cycle, actually, I think you already study about this in the elementary school or the junior high school, because as I remember, I already know how the rainfall happen, how the cloud is forming, and how can the like the what is evaporation, um, what is precipitation. I think I already learned about that in the high school or junior high school. But here we can study deeper about the water cycle, and we can also talk about each process here, because in the water cycle there are a lot of process going on. For example, in the ocean there is water, and if the sun is bright enough, it can make the water evaporate to the sky, and it is also can be condensed into the cloud. And because of the atmosphere and the differences of the pressure, this cloud is going from one place to the other place. And principally, the cloud is going from the higher temperature to the lower temperature. So it's from the ocean to the mountainous area. And there is also one cycle here. It is called evapotranspiration. From the evaporation, there is also one evaporate. But for evapotranspiration, there is evaporation and transpiration, which is done by plants. So transpiration is done by plants, and there is evaporation plus transpiration. So it becomes evapotranspiration. There is also sublimation and desublimation. Sublimation and desublimation. And there is precipitation. It is caused by the cloud. Yeah. So there is cloud which contains rains, and in the exact place, it can cause rainfall, which called precipitation. But precipitation is not always rainfall. There are also a lot of type of precipitation. For example, snowing. Snowing is also part of precipitation. Or hail. Hail is when there is rainfall, but it's not water, but ice. It's called hail. And what else? Rainfall, hail, and yeah, snowing. And if it's snowing in the mountainous area, it's not always snowing also in the other region. So sometimes if it's snowing here and the temperature raise, of course the snow will melt, and the snow melt runoff will produce water to the stream flow. Of course, the water will be running from the higher elevation to the lower elevation. And from this snow melt runoff, the water is going to the stream flow, and it's going to the bigger water surface, such as here is the ocean. So from the river freshwater, it is going to the ocean, and it's also evaporates because of the sun. The other snow melt runoff, the water from the ice and snow, going into the ground, infiltrates into the ground. The process called infiltration. It becomes the groundwater flow. So the groundwater flow is such an example for the invisible water. So in the beginning, I already said that hydrology is not lesson about visible water, but also invisible water, which is water that is contained in the ground, namely groundwater. In this groundwater flow, um, it can infiltrate to the seepage or going to the springs of the fresh water. It also can flow going to the ocean. So the groundwater flow is not only going to the river or fresh water, but it's also going to the ocean. And then from the ocean, the cycle continues again. From the ocean, the water evaporates and then consists of clouds. And after the evaporation, and after the clouds going from the atmosphere from one point to the other point, and then the clouds are causing precipitation, and then there is snow melt, and the water infiltrates, become the groundwater flow, and then from the groundwater going back to the ocean, and so on. That's why it becomes the water cycle, because the cycle is continuous. So it's going round and round, and it doesn't stop. Uh, After all, the water is always there, like because the water, if there is still water, there is still a water cycle going on there. And if from my description is not enough, it's not clear enough, we can watch the video about how does rain form and what is the water cycle. The sound.
Let's look at the science of rain and how raindrops form. First, we'll need the sun. When the sun shines on water on the Earth's surface, the heat of the sun warms the water, turning it into an invisible gas called water vapor. This process, the changing of water into a gas, is called evaporation. Because gases are lighter than liquids, water vapor rises up into the sky. And the further you move up and away from the Earth's surface, the colder the temperature gets. So in the sky, the water vapor cools and changes back into tiny water droplets. This change is called condensation and is the opposite of evaporation. Clouds are made up of tiny water droplets, so when condensation occurs in the sky, clouds form and grow. Let's take a closer look. When water droplets bump into one another, they stick together and grow in size. They continue to grow until they are too heavy and fall as rain. They even grow as they bump into one another on their journey from the cloud to the ground. And every single raindrop that reaches the ground is made up of 1 million of the original tiny water droplets. Raindrops fall on the ground surface where the sun can shine on them, and the whole process happens again. This is called the water cycle and keeps water moving from the ground to the sky, providing the water needed for plants, animals and people to survive. So now you know.
Ya, jadi seperti itu proses terjadinya hujan dan apa sih water cycle itu. Jadi ya itu versi singkatnya. Nah, water cycle bisa disebut juga sebagai hydrological cycle. Jadi di sini ada gambar sebuah siklus dan ada nomor-nomornya. Biasanya kalau pas kelas offline sih saya minta maju ya, jadi nulis yang 1 apa, 2 apa, 3 apa. Di sini kalian bisa nggak pakai annotate, terus nulis di sini 1 apa, 2 apa. Aktif nggak annotate-nya? Oke.
Aktif, Ma'am.
Oke.
Yeah.
Yeah. Hydrological cycle is it's the same with the water cycle. So there is a process from 1 until 11, I guess. Yeah. Maybe you can mark which one do you know. Like maybe for the 1, you can write here what's the name of the process, and number 3, what is this, and then the 5, what is this process name, and yeah, it's it's not mandatory, but yeah, if you can help to answer, it's good. It will be good. Evaporation, okay. Number 2. So there is evaporation and something to do with plants, and that's the number 2, I guess. Condensation, okay, yeah, it's the process of the cloud forming. Okay, rainfall, yes. Maybe here, what's happening below the ground? Yeah, this one is also evaporation. That's correct. Yeah, you don't have to answer all, but you can write what you know. Evapotranspiration, yeah, okay. Okay, thank you. What's happening in the ground, below the ground? Groundwater. Okay. Yeah, so from the groundwater, it's going back again to the river or the sea, right? Okay, infiltration, yeah, that's correct. Yeah, so it's pretty complicated here because in the water cycle, in the previous water cycle, it only contains of infiltration, I guess. But here there is percolation and the other the other process, I guess. So it's become a little bit complex here, but it's okay. Yeah, I think it's enough. Thank you for your participation. Yeah, so here we have evaporation because of the water from the sea gets heated from the sun. And here we have condensation, the cloud formation, and in the because of the atmosphere, the cloud can form rain, and then rainfall happen. And there is also evapotranspiration going on here because of the transpiration which is done by the plants, yeah? And the water from the rainfall going through the soils through infiltration, and there is groundwater flow here, and it's going back to the ocean. Okay, thank you. I'll clear all things. Yeah, so this is the answer. From 1, 2, 3, cloud, rain forming cloud, precipitation. Yeah, for the second one is the overland flow. So not all the water from the rainfall is going to the soil, but there is also going in the surface of the soil. You can see here the number 7. Number 7 is going in that direction, but the number 6 is going inside the ground. So the differences here are for number 6, it's going inside the ground. It is called infiltration. But for the number 7, it's going through the surface of the soil. It's called overland flow. So the flow above the land. And there is number 8, interflow. So interflow, it's like a groundwater flow, but it's above the water sea level. Like here we have the water sea level, and it is still above that. It is called the interflow. And overland flow plus the interflow will be the surface flow because of the um, rainfall effective. And 9, we have moisture content. 9, we have moisture content. It is because of the water coming into the soil. So it can make the soil moisture. It's moisturizing the soil. So that's why it's called moisture content. And the number 10 is percolation. Percolation is when the water from the above the ground, it's going inside the below below the groundwater level. And there is groundwater flow. It's water flowing from the groundwater. Oh no, water flowing from the ground going to the ocean and the river. Yeah. And here we will introduce ourselves to the water balance. So what is water balance? Water balance here is the like the when the water is going or it's going out from the system, the amount of water going into the system is also the same with water going out. If it's not the same, there is the change in the storage, or here we got the delta S. If the delta S is 0, so the inflow is the same with the outflow. So it's called it can be balanced. The inflow is balanced with the outflow. But if it's not 0, it has the change in the storage delta S. So the delta S can be positive or negative. That's why this one is called water balance. Here we got from Van der Chow in 1964. Inflow minus outflow equal to plus or minus delta S, change in storage. What do you call inflow and what do we call outflow? Here you can see the inflow. The inflow is water going in, but the outflow is water going out. For example, okay. For example, here we have 2 systems, right? One is the plants in the land, and the other one is the ocean. Yeah. In the ocean, we have inflow from the precipitation, E, and we have the outflow from the evaporation. So because of the evaporation, the water in the ocean is decreasing, right? The water going up into the air, evaporates into the air because of the evaporation, and it is forming cloud. And here in the land, we have also inflow from the precipitation, and outflow from the evapotranspiration, because here we have plants. Here we only have evaporation because there's no plants. And how do we calculate the precipitation in the land? Precipitation in the land, we can calculate it with the so the precipitation equals to evapotranspiration plus surface runoff. Surface runoff is the precipitation which is going above the ground and entering the water bodies, here entering the ocean. And we also have the groundwater flow from the precipitation, which is going inside the ground, and it is flowing through the groundwater flow, coming into the water bodies. Here is the ocean. And we have the change in storage. If the change in the storage is positive, so it means the inflow is bigger than the outflow. So in this case, the precipitation is bigger than the evapotranspiration. But if the change of the storage is negative, it means the inflow is less than the outflow. So the water coming in is less than the water coming out. So the change in the storage we can see here in the ocean, the changing in the elevation. So if the surface runoff and groundwater flow is bigger than the evaporation, it is also there is also a lot of rain. So it can conclude that the delta S will be positive because the inflow is bigger. But if there is no rainfall, for example, in dry season, there is no rainfall, so the surface runoff will also be almost zero, and the groundwater flow is not that big rather than in the rainfall season. So of course, the evaporation can be bigger than the precipitation and the surface runoff and groundwater flow. And there will be change in storage. The delta S will be negative. So probably the water level in the ocean will be decreasing. And regarding watershed, so in the watershed, we have here maybe in Indonesia, we usually call it das. Das is daerah aliran sungai atau daerah pematusan di Indonesia. But usually it is called watershed or catchment area or drainage area. Principally, it's the same. It is the boundary between the area from each river. Like here, we have one river, one main river, and there are tributaries area here. And from this tributary, the water flowing, remember the water is flowing from the higher elevation to the lower elevation. So if there's the river here, of course, the higher elevation is the tributaries area, and the main river is lower than that, and the outlet is the lowest one. So the water is flowing from the tributary to the main river and going to the outlet. And here we have the watershed boundaries. And how do we determine the watershed boundaries? We will talk about it later. But here, if we have rainfall, here the rainfall in this area, and there is one river in this area. For example, in this area, we have one small river here. Of course, the water coming from the rain will be flowing through the river. It calls the surface runoff because we can see it on the surface. But the other that we cannot see, the groundwater flow, is also going to the river. And here we have the contour or the elevation of the soil. When the contour is highest, it is at the highest, we can use it as the boundary of our watershed. Here we can see if the rainfall happen in our area, the rainfall here will be going to the other side, but this rainfall here will be going to this side because of the contour of the soil. Same with this one. The water from the rainfall here will be going to the right side, but the water from here will be going to the left side, going into the river here. That's why we can make a boundary of the watershed as the highest elevation of our area, because at the highest elevation, the water flowing in different direction. Yeah. For example, here we have Balikpapan contour map. In Balikpapan, there is river called Sepinggan River, Sungai Sepinggan here, the purple one. So this Sepinggan River have few tributaries area. Here we can have Sepinggan 3, Damai 3, Sepinggan 2. And from this big Sepinggan River, we can make the watershed boundaries. How can we make that? Here we can see the watershed boundaries is drawn from the outlet to the outer side of the river, which has the highest elevation. Okay, and here it's not that clear, but in the original contour map, this one is contour map. In the original contour map, usually you can see the number of the elevation. For example, here they put number 50 here, and then they put number 49 there. Oh, so this one is higher than here. So we can make this one as the watershed boundaries like that. So you can look for the line with the highest elevation, and you can make that line into your watershed boundaries. Here, for example, the watershed boundaries considering the shape of the tributary of our river is the red one. So this is the outflow. As you can see, the river has tributaries from here to this area, and then to this area, and you will put your boundaries into the outer part of your tributaries area. And from this watershed shapes, there are also characteristics for different shapes. Here you can see what is this shape. I think this shape is a little bit radial, right? Like it has some big side and not so long, but it's big in the horizontal direction. The first one, the watershed shapes, is the bird's feather atau bulu burung ya, karena bentuknya mirip dengan bulu burung. Because of its shape similar to the bird's feather, so it names bird's feather. The tributaries on either side of the main river flow into the main river. So it has only one tributaries, but it has long tributaries area. So here on our example, it has not only one, but like you can see, it has branching here and here. But for the bird's feather, it's only branching one and then smaller. The flood discharge is small because the arrival time of the floods from the tributaries is different. Yeah, because of the long distance between the outer side of the watershed to the outflow, because it has this long. The flood discharge is small, but the flood lasted a while. It is small, but it lasted a while, so it took long to reach this outlet because of the long of the distance here. It is a little bit different with the radial one. The watershed shapes radial. It is the shape of the watershed resembles a fan or cycle. I think it's similar with our example here. Tributaries concentrate to a point radially. But in the bird's feather, it's rather long. But in this radial, it's rather radial or circling. Large floods occur at the tributary meeting point. For example, here in the meeting point, and here in the meeting point, here in the meeting point. This one is also at the meeting point. The other one is parallel. This shape has a pattern where two parallel river flow paths unite at the downstream side. Flooding occurs at the meeting point of the tributaries here. So this parallel is similar with the radial, but this parallel is rather like twin rivers here. But the radial is not that similar, but it's rather circular here. So you can see the differences between radial and parallel. And the last one is complex. So complex is, it has several shapes from the other three shapes. So it can be mixed between bird feather and radial, or radial and parallel, or between the three of them. So I think this one is not that complex. If this one is more long, it can be the bird's feather, and this one can be the radial one. But yeah, it depends on how you see it. And what's differences between watershed and river basins? So we've done talking about the watershed. Here we have one watershed consists of two tributaries. Here we have also one watershed. And what is the differences between watershed and river basins? The watershed is consists of a watershed, but the river basins consist of a lot of watersheds. So if there are a lot of watersheds in one river, like one big river, it's called river basins. Here we can see watersheds from the highest elevation of the contour. The water is flowing, divided into this side and to the other side. And from one side, we can see that this water going into this river, and from this river, the water is going to the ocean, or this big river here. This is called a watershed. But if you have here we have pictures of 1, 2, 3 watershed. So here we have this watershed going to this ocean, and this one is going also to the same ocean, and this one is also going to the same ocean. Now, this is called river basins, which is consists of maybe if we follow this graph, we can see like 1, 2, 3, 4, 5 watershed. So it consists of 5 watershed and 1 river basins. So this is the differences between a watershed and a river basin. And how we determine the watershed boundaries, as I already told you before. But this is the example if we have 2 watersheds next to each other. So maybe this one, like 1 and 2. How can we make the boundaries, and how can we determine this water is going to that side and this water is going to the other side? Here we can see the rainfall, the blue one. When the rain is pouring to the soil, this is the soil, and this is the small river. This is the watershed 1, this is the watershed 2, because they go through the different tributaries or different river, right? So here, if we have the rainfall, and we can see that the water from the rainfall is going to the different direction. Here we can see the water is going to the watershed 1, and here we can see the water is going to the watershed 2. But it is only the surface runoff. How about the groundwater? The groundwater is a little bit tricky because it can be seen, and the groundwater flow, it is also not depends on the elevation. It is really depends on the type of the soil on your ground. So it can be the water pouring here is not all going to this watershed, but some part of it is going through the soil into the groundwater flow, and it will be going to the other watershed. It is possible also. That's why when you determine the surface runoff, there will be coefficient, and the coefficient is really based on the type of your soil, or depends on the material of your surface. For example, if we have here road, not that, yeah. For example, road, the asphalt one, it will be different with this one, maybe the road only with the paving block. So the coefficient will be different between the road with the asphalt and the road with the paving block. That's why, because it considers the coefficient of the water going into the soil, and the coefficient of the water going in the surface. It will be learned more truly in the next lesson, I guess. Yeah, I think for today that's enough. That's all from me for today. Maybe there is a question from you. Don't hesitate to ask. You can ask me regarding the material from today. I will upload it in the classroom with also the ebook, and yeah, maybe the video also. So if you have any question, you can ask me, raise your hand, or you can talk directly. Okay. Usually there is no question in the beginning of the class because it's still introduction, but I don't know, maybe you have questions. I hope it's clear. Yeah, Firman Syah Muhammad.
Oh yes, thank you, ma'am, for the presentation and for the knowledge that you have told. I would like to ask, a question. What is the difference between each culvert? We believe there is a box culvert and then trapezoid culvert. And what is the difference between them and how it impacts the water drainage or
Yes.
flow? Yes, that's all. Thank you.
Okay, thank you for the question. I think it's a little bit advanced in this hydrology area because it's more drainage, but it's okay for me. Let me show you the picture again. Culvert here. This culvert. This is the culvert that you meant to, right? Yeah. The differences between box culvert and the circular one. There is no trapezoid culvert. Yeah. In the fabric, there's only two types, I guess. The box one, the square one, this one, and the circular one. What is the differences? Actually, it depends on your necessity because when you build a culvert, it also depends on the dimension of your channel, right? Because when you have culvert, the dimension usually it's not that big. It has to be smaller than your channel, so the water can flow through the culvert with the higher velocity and higher water level. That's why it's usually smaller than your channel. But when will you use the square one or when will you use the circular one? It depends on the dimension that you need because the culvert is made by the fabric, like the material. We didn't make it by ourselves. Usually in the field, we buy it from the construction firma, or we need, for example, we need the dimension of 1 meter and 1 meter. Oh yeah, we have. But when we need the dimension of, for example, 0.85 meters, and then oh sorry, we don't have the box one. We only have the dimension, that dimension in the circular one. So in that case, okay, we can use the circular one because of the dimension that we need. So when we design the culvert, we first of the step is we estimate the discharge, and then after we know the discharge, we know the dimension of the culvert that we need. And after that, we know the dimension of the color that we need. We can see from the brochure. Usually they cut us a brochure from which dimension and which shape that match with our necessity. So yeah, that's why we can use the box one and we can also use the circular one. It depends on the dimension that we need. But the differences, I think it's not that different. But when you calculate the culvert, you need to calculate also the friction. Usually, it has the different friction coefficient, and it also can be different with the material. For the culvert with the box shape, you can only use this concrete material. But for the culvert with the round shape, you can use the pipe one. And I think there is not only one, but there is also another option, not only concrete, but also with iron material. for the circular shape, but for the box covered, I think it's only concrete material. That's the difference. Okay, I hope it's clear. Or you have more questions?
It's clear. Thank you.
Okay. Yeah. Is there any more question? Yeah, I hope what I told you today about my presentation, it can be received well. If I told you things too quickly or too complicated, you can always tell me to slow down, because usually I talk a bit faster, but I try to slower the pace now. But if it's too fast or you cannot understand clearly, you can always ask me in the mean of my presentation. Okay, what time is it? I think if there's no more question. So yesterday, one of your friends has already contacted me. I think it's, what's her name? Yeah, it's regarding the information about this class, Angelina. So regarding the information about this class, I will tell Angelina, and Angelina will tell it to you. Maybe there's something I post in the classroom, or maybe there is some assignment, or maybe some materials that I uploaded. I will tell Angelina, and Angelina will tell it about to all of you. Yeah. You already fill in the presentation, the intip.in/presensi21. I will put it on the chat box again. Yeah. So if you already fill it, thank you very much. I appreciate it. And yeah, we can see each other again on the Thursday. I guess it's at 2:30, right? 13:30. Yeah. Thank you very much for your attention. I'm sorry if there is a lack of something here that I did. And see you on Thursday. Keep healthy, keep safe, and have a nice day, you all.
Thank you, ma'am.
Wassalamualaikum warahmatullahi wabarakatuh.
Have a nice day.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, ma'am.
Thank you,
Have a
man.
nice day.